Hello, this is Mr. Reynolds, and we're going to do some measuring today. And before we go any further, you need to pause this and you need to get a periodic table and a calculator. Okay, periodic table and calculator. Okay, now that you've got those, first of all, you have to use this today, and you've done it some before. So I just wanted to review that with you now, and this is finding out molar masses of substances, okay? And if you don't remember how to do that, we'll do a couple quickly here. One of them, let's do carbon dioxide, and there's one carbon present, two oxygen, there's carbon oxygen present, there's one carbon, there's two oxygens, each carbon has a mass of 12, each oxygen has a mass of 16, 1 times 12 is 12, 2 times 16 is 32, the mass of carbon dioxide is 44. Okay, the molar mass of carbon dioxide is 44. A second one, let's do aluminum oxide. There's aluminum present and oxygen present. There's two aluminums. There's three oxygens. Each aluminum rounds to a mass of 27. Each oxygen has a mass of 16. Okay. 3 times 16 is 48. 2 times 27 is 54. The molar mass of aluminum oxide is 102. Okay. And a third one that we can use also, simply water. Okay. There's hydrogen present. There's oxygen present. There's two hydrogens. There's one oxygen. Each hydrogen has a mass of 1. Each oxygen has a mass of 16. When I add up the masses, I get a molar mass of water as being 18. Okay? And hopefully you remember how to do that. And we do it nice and neat while we're doing that. Okay? Next slide. The other thing that you'll have to deal with today, actually, you're not going to deal with that today. Is a conversion factor. Is a tougher math thing. Let's go straight to this chart that you're going to use. It turns out, it looks like this is really complicated. It's not, especially if you use this chart on it, which you're going to use again and again and again. Okay, so get used to it. Okay, whenever we go to the moles box, we're dividing. Whenever we go away from the moles box, we multiply. Whenever we go to the moles box, we divide. Whenever we go away from the moles box, we multiply. Okay, down here is going to be number of particles. Okay, particles, why call it particles? Because I'm not sure if we're talking about how many atoms we have. That's what's on your periodic table, individual atoms. Like nitrogen, you look it up on the chart and its mass is 14. Or we could have molecules, which we're only supposed to use that terminology when we have nonmetals bonded to nonmetals, like you just did carbon dioxide, nonmetal to nonmetal, and its mass was 44, right? Or when we did some ionic compounds, which was metal to nonmetal, such as this one that we did, aluminum oxide, okay? And we had its mass as 54. Oh, this was the 102, right? Okay. And so we found whether it's a molecule or ionic compound, we're supposed to be careful with the terminology, but we work it out the same way, okay? So all this works the same way, but this question mark down here in the particle box, this is pretty much play on words, okay? Is it ionic compound? Is it molecular compound? Now, one thing that we'll learn here with ionic compound, I'm supposed to refer to this as formula unit. You haven't learned this yet, but Al2O3 is the smallest whole number ratio of aluminum bonded onto oxygens. That is the formula unit for aluminum oxide, Al2O3. The formula unit for sodium chloride is NaCl. We take the lowest whole number ratio. Okay, and sodium chloride is 1 to 1. Sodium loses 1, chlorine gains 1 electron. Okay, and Al2O3. Let's see, you remember oxygen can gain 2, aluminum loses 3, so total 6 loss, 6 gain. Hey, that works out great. Okay, but this is, again, this is terminology that we're supposed to be using. The way we work stuff out is the same. Okay, up here in the, again, from the mass going to moles or back and forth, a conversion factor that we have to use in here, whether I'm multiplying or dividing, is going to be the molar mass, which you have already shown that you know how to figure out, okay, because I showed you that in a few minutes one day and then you had it. All right, let's say that, let's say our problem is, number one, we have, we use triple beam balances. I gave you some table salt, some sodium chloride. You weighed it out and you got 2 grams of it, okay, on the triple beam balance. Well, way to go. Hey, if we have mass of something, we can find out its moles, and we can find out just how many particles, how many NaCl formula units did I actually have there in that 2 grams. How much of it was on the scale? We can actually figure that out, okay? So the first step is going from mass over to moles, so we'll do that. I need the molar mass of this, so I'm going to be nice and neat. Okay, I need to find the molar mass of sodium chloride. I got 2 grams, and I need to know 2 grams. And I'm going to the moles box. I'm going from the mass over to the moles box, so I need to divide by its molar mass. So let's find that. So being nice and neat, like I taught you, so you can catch any mistakes. There's Na present and there's Cl present. There's 1 sodium present. There's 1 chlorine present. Sodium has a mass of 23. Chlorine has a mass that rounds down to 35. Okay, and that up 58. So the molar mass of sodium chloride is going to be 58. The molar mass of sodium chloride is 58. Okay, so we're going to take the mass of 2 grams of sodium chloride divided by its molar mass of 58. So I'm going to have 2 grams divided by 58. Okay. Now you punch it in your calculator. 2 grams, 2 divided by 58 equals 0.034. 0.034. Okay. And this is going to be moles. 0.034 moles of that. Okay, I'm going to the next page, and we're going to keep this a little bit neater. So again, do the chart again. Like I said, you're going to do it again and again and again. If you find out the mass, you can find out anything. Yeah, you got to convert to moles first of all. And moles is a standard unit. They're trying to find something that all molecules and atoms and ionic compounds that they all have in common, and really the only thing they can find in common is the number of them. It's kind of like donuts. There's what's a dozen donut? Oh, that's 12. A dozen pennies is 12. A dozen tires is 12. A dozen pencils is 12. So dozen means 12. Moles means something like that also. I'm going to put this number in here. We're not going to use it yet, but 1 mole is going to be equal to 6.022 times 10 to the 23rd. Wow, that's a big number, okay? We'll deal with that in our next lesson, dealing with the math stuff. I want you to get better at going from mass to moles up here, just this top section right now. That's enough for us to do. I'm going to give you some problems to work on for those. All right. Couple more problems here, and let's go with a second one. Let's say that you weighed out in triple balance. Let's say that we did water. You had 50 grams. You had a graduated cylinder that was 30 grams. You poured some water in there, and it went up to a total of 50 grams minus the 30. Oh, you got 20 grams of water is what you found. You got 20 grams of water. That's mass. 20 grams of water. How many moles is that? Okay, we're going to need the molar mass of water which we did on the first page, and we found that was 18. Okay, so we're going from 20 grams of water over here to the moles box we divide. To the moles box we divide, so 20 grams of water divided by 18. Okay, 20 divided by 18. Punch that in your calculator. That's going to be a number greater than 1. 20 divided by 18 equals 1.1, repeating, 1.11, capital M is moles. All right. Let's do a third one. Let's have aluminum oxide, which we already found. Let's say that you weighed out 3.2 grams of that. 3.2 grams of that on the balance, and we already worked with so 3.2 grams divided by its molar mass, and you figured out its molar mass on the first page, and you figured that out to be 102. Okay, so punch in the calculator. 3.2 divided by 102 equals 0.03. There's a lot of other numbers after that. The next one is a 1. We're going to round it to the 3 and keep it 2 numbers past the decimal. Okay, so 3.2 grams of aluminum oxide is going to be 0.03 moles. All right, and that's how we do that. I'm going to give you grams. You divide it by the moles. All right, so you're doing this stuff only. Okay, so you're going to go to online day 4/7/2020 and work out the problems that I give you there. Okay, I'll also stick some on a homework page for you to do that also. All right, thank you very much.